Summer seems to be settling in. The wildfire threat just increased to moderate for Grand Teton National Park, Teton National Forest, and the National Elk Refuge.
The crack across the surface of the Grand Teton Range did not arrive quietly. Scientists monitoring the rugged Wyoming landscape have long warned that this mountain chain is not as immovable as it looks, but few expected such a sudden and dramatic split to appear. The ground ruptured across an exposed slope with a jagged tear, a visible reminder of the immense geological forces hidden beneath one of North America's most iconic ranges. For hikers, climbers, and casual onlookers, it was a startling sight. Rock that once seemed eternal revealed as fragile and unsettled. For scientists, it was a warning that the region is carrying stresses far greater than most realize. Stresses that could cascade into more serious hazards if ignored. Before we start, smash the like and subscribe buttons for more updates. The Teton Range is already known to be a young and restless mountain system, having risen over millions of years along a major fault line that still defines the valley floor below. The Grand Teton itself towers nearly 14,000 feet above Jackson Hole, but that striking vertical relief exists because of faulting. When a new fracture tears open in such a landscape, it isn't simply an isolated crack. It is evidence that deep tectonic pressures are at work. Seismologists studying the split have traced its alignment to the Teton Fault, a structure capable of producing earthquakes of magnitude 7 or greater. To see the Earth literally break apart on the surface is to glimpse the hidden hand of those forces pressing upward and outward. It is, in essence, the mountain system showing its restlessness in real time. This sudden rupture matters not only for geology, but also for the people and wildlife that call the area home. The Grand Teton region is a magnet for outdoor recreation, with thousands of visitors moving along trails, climbing routes, and campsites every season. A large ground fracture poses immediate risks of rockfalls, landslides, or slope destabilization. More importantly, it signals that sections of the mountainside may no longer be as stable as they appear. Scientists emphasize that such visible cracks can be precursors to larger mass movements, especially when heavy rainfall, melting snow, or seismic tremors act on the loosened material. The mountainside is telling a story of strain, and ignoring it could prove costly. At the same time, the warning reverberates on a deeper level. The split in the Tetons is not just a local curiosity. It represents the living dynamics of Earth's crust. In many places, tectonic activity remains hidden below layers of sediment, but here the crust exposes its vulnerability openly. Researchers studying the fracture point out that the region has not experienced a major earthquake in recent human memory, yet the geological record shows repeated massive quakes along the Teton Fault. The crack, then, becomes a symbol of stored energy. It may not herald an immediate quake, but it reminds everyone that the region sits within a dynamic and potentially dangerous system where sudden releases are inevitable. The dangerous aspect is not only the potential for earthquakes, but also the cascading hazards that can follow. A fracture at high elevation can destabilize cliffs and glaciers, creating conditions ripe for avalanches or rock slides. These in turn can dam streams, redirect rivers, or unleash sudden floods. In a landscape where ecosystems are delicately balanced, such disruptions ripple outward. Elk, moose, bears, and countless smaller species rely on seasonal migrations and food supplies that depend on predictable landforms and waterways. A sudden geological shift can alter those patterns overnight, reshaping entire valleys in ways that force wildlife into new and often more hazardous paths. For the human communities in Jackson Hole and surrounding areas, the warning cuts even closer. Towns, roads, and infrastructure have all been built with the assumption of mountain stability. While residents are aware of winter avalanches and seasonal hazards, a large-scale fault movement or landslide could devastate transportation networks and disrupt tourism, the lifeblood of the local economy. Emergency planners now have to factor in the very real possibility that the mountains themselves could shift dramatically. A fracture high on a slope may not yet have collapsed, but its existence raises urgent questions about when and how such instability might translate into disaster further downslope. Geologists stress that such an event should shift public perception. Mountains are often seen as symbols of permanence, yet in geological terms they are fleeting, restless features sculpted by ceaseless motion. The Tetons especially rise abruptly from the valley floor because of rapid uplift and faulting compared to many older ranges. Every sharp ridge and sheer face is a testament to active forces that continue to this day. To stand at the base of a new crack is to confront the uncomfortable truth that the land beneath our feet is neither fixed nor safe, but in constant flux. That awareness is unsettling, but it is also necessary for responsible stewardship of the land. The crack also poses challenges for scientists themselves. Monitoring fault lines in rugged mountain terrain is notoriously difficult, with instruments often placed miles apart and data coming from scattered seismic stations. A visible rupture offers a rare chance to align models with reality, to test predictions against physical evidence. Teams are now deploying additional sensors and drones to map the fracture in detail, hoping to understand whether it is an isolated surface expression or part of a broader reactivation of the Teton fault system. That knowledge could prove crucial not just for Wyoming, but for the wider study of mountain building processes worldwide. Beyond immediate scientific interest, the implications stretch into broader societal questions about risk and perception. People are generally unprepared for natural hazards in regions that appear tranquil. Just as coastal communities often underestimate tsunami threats, or desert towns overlook flash floods, mountain towns sometimes forget the immense tectonic engines at work beneath them. The Grand Teton split is therefore a powerful reminder that preparedness must extend beyond the familiar. It challenges communities to consider the low-frequency but high-impact dangers that come with living near active fault lines. Another layer of danger lies in how such an event might be misunderstood. A crack on the mountainside can draw curiosity, even tourism, with people eager to photograph the raw wound in the earth. Yet approaching such a feature can be perilous, as overhanging rock slabs or unstable soil may give way without warning. Scientists caution against treating it as a spectacle. The danger is compounded by weather. Rain or snowmelt can seep into the fracture, widening it, lubricating it, and increasing the likelihood of collapse. What looks like a still moment in time is, in reality, a dynamic and potentially lethal process. For indigenous groups with long histories in the region, the rupture may also resonate on cultural and spiritual levels. The Tetons have been revered as sacred landscapes for centuries, woven into traditions that view mountains not as static backdrops, but as living presences. To see the land split could be interpreted as a sign, a call to respect forces larger than human control. While science frames the event in terms of geology and hazards, cultural perspectives remind us that such upheavals are also part of a deeper relationship between people and place. The danger, then, is not just physical but also symbolic, challenging human assumptions of dominion over the land. From an environmental perspective, the fracture raises pressing concerns about how climate change interacts with geological hazards. Warmer temperatures are accelerating glacier melt and altering precipitation patterns in mountain ranges worldwide. In the Tetons, this means more water infiltrating cracks, more freeze-thaw cycles prying apart rock, and greater instability overall. The sudden split could therefore be a harbinger of more frequent ruptures as climate and geology interact. The danger is that such combined stresses make prediction even harder, pushing the system toward thresholds where sudden failures become unavoidable. The Grand Teton rupture also highlights the paradox of beauty and danger that defines so many natural wonders. The same forces that create towering peaks, sheer cliffs, and dramatic valleys are those that threaten collapse and destruction. Visitors marvel at the grandeur without realizing that the vertical faces are inherently unstable, products of constant uplift and erosion. A split in the mountainside strips away that illusion, showing the raw mechanics behind the scenery. The danger in this sense lies in forgetting that beauty is often the visible trace of ongoing violence within the earth. In the realm of scientific communication, the challenge now is to convey the seriousness of the warning without inciting panic. Telling the public that the earth has split open in a beloved national park risks sensationalism, yet downplaying the danger invites complacency. The balance lies in emphasizing respect for the land's volatility, urging caution, and integrating new findings into emergency planning. Scientists understand that cracks do not automatically translate into immediate catastrophe, but they also know that ignoring such signals has historically led to tragedy elsewhere. The Grand Teton fracture is not just a curiosity. It is a message written into the landscape. Over the coming years, monitoring will determine whether the fracture stabilizes or expands, whether it was an isolated adjustment or the beginning of more dramatic fault activity. But even without knowing the full trajectory, the meaning is clear. The Earth has given a warning, revealing its hidden power through a visible scar. That scar reminds us of our vulnerability in the face of geological forces, forces that operate on scales of time and energy far beyond human control. The danger lies not only in the rock that may fall, but also in the human tendency to forget, to assume stability where none exists. As researchers camp near the site, taking measurements and running models, the image of the split remains etched in collective memory. A dark, jagged line across pale granite, it interrupts the illusion of permanence. It is a reminder that mountains rise because the Earth is restless, and they will continue to shift as long as those forces remain. For now, the Grand Teton fracture stands as both a scientific puzzle and a natural warning. It is more dangerous than it looks not only because of the physical risks it poses, but because it reveals just how much we take stability for granted in a world built on constant change. The appearance of a fracture across the rugged face of the Grand Teton is not simply a momentary spectacle, but an unfolding narrative that draws attention to the complexity of Earth's crust in mountainous regions. The Tetons are young by geological standards, still in the throes of uplift and adjustment, and the split represents a tangible signal of that ongoing process. To understand the magnitude of such a rupture, it is necessary to step back and place the event within the broader framework of mountain building, tectonic stress accumulation, and the fragile balance between geology, ecology, and human activity. The forces that created the Tetons have not gone dormant. Beneath the surface lies a system of fault planes, pressure points, and fractured rock zones where stresses are constantly shifting. The crust in this region is under compression, with massive slabs of rock grinding against each other. Over thousands of years, this pressure builds to a breaking point, sometimes relieved in sudden earthquakes, and at other times expressed in visible ruptures, like the one now cutting across the mountainside. When such a crack emerges, it is not merely the product of surface erosion or weathering. It is an indicator that the deeper system remains dynamic. This dynamism is precisely why the split is more dangerous than it looks. It tells us that the very foundation of the range is adjusting and may continue to do so with unpredictable consequences. What makes the Grand Teton particularly striking is how abruptly the mountains rise from the valley floor of Jackson Hole. Unlike older ranges with foothills that grade into peaks, the Tetons vault skyward in steep, dramatic relief. This sharp uplift is the result of fault displacement, where one side of the fault drops while the other rises. The fracture seen today is another expression of that same process, a visible reminder that the mountain's sheer profile exists only because of violent geological forces that remain active. Tourists admire the bold skyline, but scientists see the razor edge of instability. A split in such terrain signals that the mechanics shaping the peaks are still at work, and when they release energy, they can do so on a scale that redefines the landscape. One of the more subtle dangers of the crack is its ability to alter water flow within the mountain. Fractures become conduits for snowmelt and rainfall, channeling water deep into the rock mass. Over time, that water can erode fissures, freeze and expand during winter cycles, and steadily pry apart blocks of stone. This hydrological influence means the crack will not remain static. It will evolve, widening in places and undermining adjacent rock faces. In high alpine environments, such processes can destabilize entire cliffs, setting the stage for rock avalanches that thunder down with little warning. The danger lies in the invisibility of this progression. What looks like a stable scar to the casual eye is, in fact, an open wound that the mountain's internal fluids will continue to probe. From the perspective of ecology, the consequences extend even further. The Teton Range is a critical habitat corridor, linking Yellowstone ecosystems to the greater Rocky Mountains. If the fracture destabilizes slopes or triggers landslides, it could sever or alter migration pathways for elk, mule deer, and bison. Vegetation patterns could also be disrupted as debris covers alpine meadows or reroutes streams that nourish valleys below. Small shifts in plant and water distribution cascade into larger effects across predator-prey relationships, hibernation cycles, and breeding grounds. For grizzly bears or wolves, a fractured and altered landscape could mean more difficult hunting conditions, while for smaller species such as marmots and pikas, the collapse of talus slopes could erase essential shelter. Thus, the crack is not only a geological disturbance, but a biological one, threatening to rewire an entire web of interactions in the high mountain environment. For climbers and mountaineers, the danger becomes intensely personal. Routes across the Grand Teton's ridges and faces rely on the assumption that rock anchors and ledges are firm. A major fracture throws that assumption into doubt. If entire rock masses are shifting microscopically, climbers may find holds breaking, slabs shearing off, or entire routes collapsing without warning. The danger here is magnified by the false sense of security the mountains can provide. A crack is visible, but its depth, trajectory, and stability remain hidden. Climbers tied to ropes and carabiners may not realize that the rock they trust is poised to fail. For this reason, guides and park officials may need to reassess the safety of well-traveled routes, altering the traditions of one of North America's premier climbing destinations. Infrastructure in the surrounding valleys is equally vulnerable. Roads that weave into Grand Teton National Park and connect with Yellowstone rely on predictable slope stability. A fractured mountain is a source of rockfall, and rockfall is a source of blocked highways, damaged structures, and sudden threats to passing vehicles. Moreover, the split suggests that the fault system beneath the region is still accumulating strain, raising the likelihood of seismic events that could damage bridges, pipelines, and utility networks. In such scenarios, it is not only the physical rupture that matters, but the ripple effect across human settlement. What begins as a crack in granite can end as economic disruption, evacuation orders, and prolonged closures of critical transport routes. Scientists studying the fracture also recognize its value as a natural laboratory. Rarely do researchers get the chance to observe such a fresh rupture in a high-profile, easily monitored location. By mapping its geometry, measuring its widening over time, and correlating it with seismic data, they can refine models of how faults interact with mountain landscapes. These models help predict not only local hazards, but also the behavior of fault systems worldwide. For example, lessons from the Tetons may inform understanding of fault-driven mountain ranges in the Himalayas, Andes, or Alps. The crack, while dangerous, becomes a source of knowledge. Knowledge that may one day save lives in distant regions where similar fractures could precede devastating earthquakes. There is also a cultural and psychological dimension to the event. The Tetons stand as a national symbol of wilderness, featured in photography, art, and literature as icons of permanence and grandeur. A visible crack shatters that symbolism, reminding people that even the most seemingly immovable landscapes are ephemeral. This confrontation with impermanence can be unsettling, yet it also deepens respect for natural forces. Tourists arriving in Jackson Hole may expect serenity, but what they find instead is a sobering demonstration of instability. That shift in perception may encourage a broader awareness of natural hazards, motivating visitors and residents alike to treat the landscape not as a backdrop, but as an active participant in their lives. The fracture also intersects with the scientific debate about recurrence intervals for large earthquakes in the region. Geological evidence shows that the Teton Fault has unleashed massive quakes every several thousand years, each capable of reshaping valleys and lakes. The last such event occurred well before modern settlement, leaving only scarps and uplifted terraces as testimony. A fresh fracture now raises questions. Is this a minor surface adjustment or a harbinger of another large event? While no scientist would claim certainty, the crack emphasizes the reality that recurrence is inevitable. It may not happen tomorrow, but it will happen. The fracture is simply a reminder that the countdown has not paused. Perhaps one of the most overlooked aspects of such ruptures is their influence on glacial systems. The Tetons host small glaciers clinging to their upper slopes, remnants of the last ice age. These glaciers rest precariously on steep faces, and a destabilized rock base beneath them could accelerate their retreat or even trigger sudden ice falls. A glacier detached by a rockslide can behave catastrophically, surging downward in an ice avalanche that obliterates everything in its path. Thus, the fracture ties into the broader story of climate and cryosphere dynamics, making the event a multi-layered hazard that straddles both geology and climate change. In addition, the crack serves as a potent case study in risk communication. How do authorities convey the seriousness of the event to the public without driving away tourism or sparking undue fear? The challenge is heightened by the visibility of the fracture. Anyone can see it, photograph it, and spread images across social media. That visibility forces officials to respond, to explain, and to prepare. In such scenarios, underreaction is as dangerous as overreaction. Downplaying the risk lulls people into complacency, while exaggerating it can cripple local economies and damage trust in science. The crack, therefore, becomes more than a geological feature. It becomes a communications puzzle, one that tests society's ability to live responsibly with natural hazards. Another angle worth considering is the historical record of indigenous oral traditions. Many Native American groups have stories of mountains that split, shake, or collapse, often framed as warnings about respect for the land. The Grand Teton fracture aligns with those narratives, offering a contemporary resonance that validates ancestral knowledge. These traditions remind us that fractures and ruptures have been part of human awareness for centuries, interpreted not only as physical threats, but also as spiritual messages. In a modern context, integrating that cultural wisdom with scientific data may enrich public understanding, presenting the event not just as a danger, but as a moment of reflection on human humility before natural forces. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on scientists' warning about the Grand Teton Earth split? We want to hear from you. Thank you for watching, and see you next time.